Let's say we're given a set consisting of consecutive integers from 1 to n inclusive. So we want to find the number of ways to partition the set so that the sums of both resulting subsets are going to be the same. So let's look at this example. We have n equals 7, and in the set we have the numbers 1, 2, 3, 4, 5, 6, 7. So we want to split this set into two subsets so that each element is in either one of those subsets, but not both. So here are the different ways we can do it. We can either do 1, 6, 7 and 2, 3, 4, 5, or we can split it into 2, 5, 7 and 1, 3, 4, 6, or we could do 3, 4, 7 and 1, 2, 5, 6, or we could do 1, 2, 4, 7 and 3, 5, 6. And we can see that each of these different ways that we split results in both subsets having a sum of 14 in this case. And so there are 4 possible subsets that work here. So as we do the problem, we're going to see that this is a typical dynamic programming problem. So basically you use subproblems, you solve those subproblems, and use their results to calculate the answer for your larger problems. So we'll sort of build up from a smaller number, and we'll do a certain step with that smaller number, and we'll keep building up until we get to our larger number that we need. And so we'll write all that out. But first, let's take a look at a few constraints that we have. So one thing to note is that if I want the sum of the first n consecutive integers starting from 1, that's going to be n times n plus 1 divided by 2. So given that we know that, let's try that out with this example. So if we have n equals 7, then that means that we're going to have a total sum of 7 times 8 divided by 2. So 7 times 8 divided by 2 is equal to 28. Now, if we want to split our total set into two sets of equal sum, then both subsets have to add up to 28. And if they're equal sum, then that means that we have 2x equals 28, where x represents the sum of the elements in each subset, and so x equals 14. So we note here that the sum of each subset must be 14. So now that we know this, there's another thing that we can note. So if particular items are in one set, then they cannot be in the other set. And if certain items are not in one set, then they have to be in the other set. So if we look at this example right here, if we look at the set 1, 6, 7, then we know that 2, 3, 4, and 5 are not in the set consisting of 1, 6, and 7. This means they have to be in this other set. So when we write this out, we can assume that we're only counting these sets because these other sets are automatically created. And so that helps us avoid repetition. So with this in mind, let's start our solution. So the way we're going to do this is we're going to set up a dynamic programming array, and that's going to keep track of our solved subproblems. And this is just going to be a one-dimensional array, but for the purposes of this explanation, we're going to split up the different states of the array in its entirety so that it makes more sense when we're actually performing our calculations to calculate those larger subproblems. So let's just scroll down here. So notice here that I've labeled two axes. So the green axis is going to represent the visible numbers. So what do I mean by visible numbers? Well, let's say we're at this point right here. At this point, I can only see the number 1. So I can only use the number 1. And then at this point, I can use both 1 and 2. And then at this point, I can use both 1, 2, and 3. And then here I can use 1, 2, 3, 4. Here I can see 1 through 5. And here I can use 1 through 6. And finally, I can use 1 through 7. So this is a very important step in our dynamic programming algorithm because it helps us calculate those subproblems at smaller numbers. So these are all those n values. And we build up to our final n value, which is 7. And we're trying to solve for 7. So that is where we end. Now, what is this blue axis? This blue axis right here represents the possible sums that we can create given the visible numbers. So, for example, maybe I could create a possible sum of 0, or maybe 1, or 2. Let's say I'm at 7 right here. Well, then there are so many numbers that could be possible sums of 9, let's say, using 7 through 1. So maybe I could have 2 plus 7, or 3 plus 6, or maybe 1 plus 3 plus 5, and so on and so forth. And then each of these cells right here, each of them are going to represent the number of ways that I can create a total sum of whatever column I'm in, given that I can see up to this many nodes, or this many numbers in my set. Now you may notice that all of these are zeroed out here, So that means that there are 0 ways to create such a total sum given a certain number of visible numbers. And the reason for this is because let's say we look at this number right here. Well, we want to create a total sum of 2, but we only can see 1. So 1 is less than 2, so there really is no way to actually do that. And same thing with maybe this number onwards. We want to create a total sum of 4, but we only have 1 and 2, so the max sum that we can get is 3. So anything that exceeds the max sum of all the numbers is not going to be possible, so we'll just put zeros for all those. So the first thing we'll do is set this first cell equal to 1, and the reason for this is because there is one way to create a set such that the total sum is equal to 0, given that we have one visible number. And that's just by not using anything. Alright, so let's start populating the rest of these cells. So each of these cells, again, is going to represent the number of ways I can create a certain sum, given that I can see a certain number of numbers here. So we'll start with 1 and 1. So the technique to use here is that we're going to assume that we are adding this new number. So we're adding a 1 to our visible numbers. Well, if we're adding a 1 to our visible numbers, then we need to subtract that from this particular value right here, and that's going to get us 0. And then we take the number that's associated with index 0, and that's a 1, and we just add that to whatever value was before this. So it may not make sense right now, but let's just write out a few numbers, and then it'll slowly start to make sense. So we'll put a 1 here. And then the next row, we have two visible numbers. We have 1 and 2. And so the number of ways to make a 0 is going to be 1. And then the number of ways to make a sum of 1 is just going to be 1, because we can just have the number 1 itself. And then 2 is also going to be just 1, because you can just use the 2. And then 3 is going to be 1 plus 2 is 3, and that's only one way to do that. So it's going to be 1 as well. On the next row, we have three visible numbers. We have 1, 2, and 3. So here, again, we can create a total sum of 0 in one way by not doing anything. And then a total sum of 1 by just using a 1. And then we can create a total sum of 2 by just using the 2 itself. And then there are now two ways to create a total sum of 3. We can either do 1 plus 2, or we could do 3. And so that's 2. And then 4, we can only do 1 plus 3, which is 4. So that's 1. And then 5 is only going to be 2 plus 3, which is 5. So that's 1. And then 6 has to be the sum of all the numbers. So that's 1. Now we'll do one more row before we explain actually what the algorithm is doing here. So we'll say that this is also 1, this is 1, this is 1. And then there are two ways to create a sum of 3, because you can't use the 4 yet. But now you can use a 4. So here, we're going to say that this is 2, because you can either do a 4 or you can do 3 plus 1. And then with 5, this is also going to be a 2, because you could do 4 plus 1 or 3 plus 2. And then with 6, we can do 4 plus 2 or 1 plus 2 plus 3. So that's also 2. And then after that, if we want to create a sum of 7, we can either do 1 plus 2 plus 4, or we could do 3 plus 4. And that's going to be 2 ways. And then after that, to create a sum of 8, there's only one way to do that. And then a sum of 9, there's only one way to do that. And then finally, a sum of 10, we have to use all the numbers. Alright, so now that we've gotten to this point, let's figure out what these numbers mean. So let's take any particular cell. Let's take maybe this cell right here. So what does this number mean? Well, essentially at this point, we are now able to see the number 4. We weren't able to see it before. So now there are two things to consider. We either use 4 in our total sum, or we don't use 4 in our total sum. And so if we don't use 4 in our total sum, that's going to be the number that's directly above this cell. So that's going to be this right here, and that's 0. That means that there are currently 0 ways to create a sum of 7, given that we're not using 4, but we're only using 1, 2, and 3. Now, what if we want to use a 4? Well, if we want to use a 4, then let's say we do 7 minus 4 is equal to 3. So now our remaining numbers in our subset have to add up to 3. Well, how many ways can we create a set containing numbers that add up to 3? Well, for that, we're going to refer to this cell right here, and that is going to be 2 ways. So then we add those up, we have 2 plus 0 is going to be 2. And so that's why this cell right here is 2. Let's look at another example. So here I've completed the 5th row where we can use the numbers 1, 2, 3, 4, and 5. So I just did this on my own. If you had done this before, then this should be what it looks like. But let's just take any arbitrary number here. So let's say we took this 3 right here, and let's figure out how we got that 3. So again, we use our technique of trying to find the number of ways to create this particular sum of 9, such that we either use this new number 5 or we don't use it. So if we don't use it, then that means we're just taking whatever we had before. So that's this number. because we only could see 1, 2, 3, and 4. So that's without the 5. But what if we wanted to use the 5? Well, if we want to use the 5, then we have to consider 5 in our total sum. So something plus 5 equals 9. So to find that something, we just take 9 minus 5, and that's 4. So we need to find the number of ways we can create a 4, and that is going to be 2. So there are 2 ways to create a 4, and that means that there are 2 ways to create a 9, given that I'm using a 5. And then if I'm not using a 5, then there's one way to do that. So those two are going to be disjoint, so that means that they cover everything. And that means that we can add these two numbers. 2 plus 1 is 3. And that's how we got this number 3. Now let's go ahead and complete this table. So here I filled out this complete table. And if you want to just try out this algorithm on any cell here, you can do that and you'll see that it works. So now that we have filled out this entire table, we need to find our answer. So remember that n was originally 7, and we wanted our sum of any particular subset to be 14. Because remember that the sum of all the numbers is 7 times 8 divided by 2, which is 28. So if we want to split it equally, then it has to be 14 and 14. So we look at row 7 and column 14, and we see that we get 8. Now 8 is not our final answer. So this right here is actually overcounting. Remember at the beginning we said that we don't want to overcount those sets because the order in which we write those sets doesn't matter. So we're going to take this 8 right here, and we're going to divide it by 2. And once we do that, we get 4, and 4 was our answer. Now before we implement this in code, let's talk about a few quick things here. So when we are looping through all of these numbers right here, so 1 through 7, we want to make sure that we are starting at one place and ending at one place. So let's figure out those two spots where we want to start and end. So we actually want to start from the rightmost place where there's not a 0, so maybe here, or here, or here, or here, or here, or even here. And we want to start from there, and we want to go backwards in our dynamic programming array. So from here we'll go this way, from here we'll go that way, from here we'll go this way, and then we'll go this way, and then here, and we'll keep going like that, and we'll keep going. Now where do we stop? We're going to stop at any place where the maximum number that is visible is equal to the total sum. So that's going to be right here, or right here, or here, or here, or here, or here, or here. Because before that, we can't actually create a sum using that new number that we got. Like for example, if I want to create a sum of 3, given that I have 1, 2, 3, and 4, then I can't actually use that 4 in any sum. So all we do there is just take the value from the top. So for example, right here, all I did was copy down this 2. Alright, so now that we've talked about how we're going to do this, let's code this out. So we can start by defining a function. We'll call it def number of subsets, and we'll take one parameter to be n. Now once we have that, we need to make our condition. So remember that the sum of each subset has to be the same, and that's only possible if the total sum is divisible by 2. So because our sum is going to be n times n plus 1 divided by 2, we need to check if that part divided by 2, again, is an even number. So the way we can do that is by just saying if n times n plus 1 divided by 2 mod 2, or alternatively, we can actually just combine this and just say mod 4 is not equal to 0. And if that's the case, then we don't have a valid n. So we can't actually create different subsets that have the same sum. So we just return 0. Now, if this is not the case, then we need to create our dp array. So we'll call it dp, and we'll set this equal to zeros times n plus 1 divided by 2 plus 1. So basically, if you remember what we had drawn out in our table before, you could see that we started at 0 and we went all the way to 28, and that 28 is going to be 7 times 8 divided by 2. And so because we're starting at 0 and going to 28, that's going to be 29 columns, so we need to add 1 to this. Now that we have this, we can say dp at 0 is equal to 1, because remember that there's one way to create a set containing a sum of 0, and that's by not having anything in the set. Now that we have this, let's start our actual traversals. So we'll say for new num in range 1 to n plus 1. So new num represents each next number that we're making visible. So we'll start with 1 because we can only use 1, and then we'll add on a 2 to that, so we can use both 1 and 2. And then we can use both 1, 2, and 3, and then all the way to 4, and then to 5, 6, and then finally to 7. So for all of this, we'll do another for loop. For total sum in range, new num times new num plus 1 divided by 2, and then new num minus 1, and then negative 1. So this basically means that we're going through all of those columns in our particular row. And remember that each column represents the total sum that's possible given the number of visible numbers that we have. And also remember that we said that we want to go from right to left, because if we go from left to right, there's actually going to be some errors in how we calculate, and we might actually end up with a final answer that is less or greater than what we want. So we'll start at new num times new num plus 1 divided by 2, because that's going to be the maximum possible sum we can create, and that's with all the numbers. And then the minimum possible sum that we really need to consider is going to be new num. So we stop right after that, new num minus 1. And we decrease by 1. Now inside this, there's just one line we have to do. We can just say dp at total sum plus equals dp at total sum minus new num. Now, why did we do it like this? Well, this actually takes care of both of the different ways to create a total sum given all the numbers that we have. So remember that there are two ways to do this. We can either use the number that we just got, so that's going to be new num, or we don't use the number. And if we don't use the number, it's just going to be whatever previous value that was. So that's just dp at total sum. And then what we're adding here is the number of ways to create that particular sum now that we have this new num. So if we have this new num, then we have to subtract it away from the total sum so that we find a particular difference. And that difference, we need to find the number of ways to create. And now that we have this, we can just return. So we'll say return dp at n times n plus 1 divided by 4. And then that divided by 2. Because remember, we're overcounting there. And that's basically it. That's all we have to do here. So let's go ahead and test this. So we'll say print number of subsets 7, because that's the number that we tested. And we'll run this, and we see that we get 4. And that's what we were expecting. And we can even try this with another number. Let's say we tried 31. And we see that we get this large number, and that is correct. And maybe we might try something like 15. So if we run that, we see that we get 361, and that is also correct. So that's it for this video, and I hope this was helpful.